Hi, everybody, and welcome to IMESH. I am Debashree Panda, and I'm the CEO of IMESH. Technology has completely changed the way we do the financial transactions. It is quite interesting that 10 years ago, when I used to transfer money from one account to another, it used to take hours, or at least to purchase goods or to purchase certain assets. It used to take some time. But today, the technology has completely reimagined, and one can do all this transaction in less than a minute. In best cases, it takes less than a few seconds, less than 10 seconds. It is interesting, how the underlying technology can, enable everybody to do their financial transactions on the daily basis. Uh, while the underlying technology, can it can support millions and millions of transactions per day. Any, security vulnerability can have a devastating effect on the financial institutions as well as on the consumers. That's why we chose this topic on securing multi-cloud banking applications with Istio. Today, our speaker is Ravi Verma, CTO of IMESH. Ravi has near about 12 plus years of experience in developing cloud native applications. He has also led many research and development projects in companies like GE Healthcare, Baxter, Samsung, etc. So, hi, Ravi.
Hello, Debashree.
Yeah. So, before we start, quickly about us, we formed IMESH in 2023. Basically, we went out of stealth mode. We have our offices in Dover, US, and also an office at Bangalore, India. Currently, our offerings are enterprise Istio support for those who are looking to kind of onboard Istio for production. We also provide IMS Istio dashboard. It's a proprietary tool for adding a visibility layer on the top of your network to find out what the network security vulnerabilities in your network. So with that, we'll get started. Over to you, Ravi.
Thank you. Hello, everyone. Good morning, good afternoon, good evening. So today's we'll be talking about more about banking and how it is translating to security and like basically how to manage the security and network complexities of the banking applications. So today's agenda is like modern tech stack for banking apps, like what all the modern stacks are getting used currently in banking sector. Then we'll talk about security challenges, networking challenges. Then we'll go for a solution, which is intro to Istio. And we'll give a little bit, if time permits, we'll go about demo. Like we'll show a demo of like how it works, basically when we apply Istio and how it works for any application. Okay, so without any delay, let's start. Okay, so modern tech stack in like nowadays, we might be hearing Kubernetes, microservices, cluster, cloud, all those things. So combined together, we are making more complex design, but in the same time, we are making it more approachable, highly available, highly performant. All those things are getting covered with all this modern tech stack. So this is a typical example we can see here. So it's not very complex. Like we have taken a kind of try to simplify it, and we have only showing here like very small part of it. Though it is in the reality, it will be more complex than this one. So here we can see a customer can interact with the banking app UI, which will in turn, all the requests will go to API gateway, and API gateway transfers those requests to all other internal services. But here we can see we have multiple places where the communications are happening between microservices, even within the microservices, from one microservice to another microservice, and from API gateway to all the microservices, which is facing towards the API gateway. So these communications can lead to, if it is not secure, can lead to man in a middle attack. So like anyone in between can read these packets and it can cause a problem. So to avoid this problem and even the networking challenges, like developer need not to worry about all the networking complexity when we are establishing communication between one microservice to another microservice. All those things can become a problematic situation when the microservices increases more and more and the complexity of the network increases. So those two aspects we'll be talking today. So let's come to the networking challenges. So in a modern or a current situation, our application can be on public cloud, even like redirecting to private cloud, even it can be hybrid also, like both it is possible. And all the microservices, they might be talking within the same cluster or outside the cluster. So when it expands across multiple clusters or multiple networks, it becomes more and more difficult to manage. And sometimes what happens, even one minor failure in one of the application or microservice leads to a kind of disaster, or like it's very difficult to sometimes debug and find it out where that issue is happening and how to recover that from. Because we don't have like visibility, like how the network is going from where to where the request is going. We can think in our mind, but we don't have anything to see and visualize. Then comes to security challenges. In security challenges, like as we were mentioning also in the beginning, like discussing, when the data is transferring from one microservice to another microservice, and if it is going to through a public channel, so it is vulnerable. Like anyone can read the data, manipulate the data, even like infer and take unnecessary actions. Firewall is not enough because it restricts to some extent, but still it can be managed to break in. And creating security policies, applying it to all microservices, it creates a burden on the developers, like managing each and every microservice to at the core level. It is very difficult for each and every. Suppose you can imagine a situation where we have thousands of microservices, and all those thousands of microservices need to be granularly controlled for each and every, like policies, what all the policies need to be applied. So it is really a tedious task. And last but not the least, it's a compliance related regulatory controls. It is very difficult sometimes to enable and kind of achieve it with a limited set of people or experience. So all these problems can be solved with the help of Istio service mesh. So Istio is a control plane, and it manages a data plane which is called which is controlled and basically managed by Envoy proxy. So what happens, Istio, what it does basically, it creates a data layer and it attaches all the proxies to a microservices, like which all the microservices we want to be secured. Those we can enable, like selectively we can enable each and every microservice to be part of the service mesh, and that service mesh will have encryption already enabled. Like if a service A wants to communicate to service B and we think that those communications are critical, it need to be secured, we can enable those two communications to go via secure channel. If we want other channels, like other microservices to be okay, even if it is not that secure, it is and fine, we can do it also that way. So what Istio does in the existing system, if we have already existing system running already fine in Kubernetes or even in the VM, so what it does, it injects a sidecar proxy. Basically, it is based on why it is attached to each and every microservices, and it creates a tunnel between all those microservices, which is secured, and it is secured by MTLS. We'll see that in some time, like how it works. So few of core features of Istio, what we can see is like a stronger identity with MTLS, like each and every microservices will have their own identity. So, and we can even restrict each and every one, like which microservice is allowed to talk to whom. All those granular control we can do. Data encryption is done with the certificates. Zero trust with authentication authorization is done, like as I was mentioning. It is, we can control each and every single microservices to talk to other services, like those kind of control we can have. We can give multi-tenancy, like if your team is having like testing team, development team, or QA team, they can work on their own areas without interfering the other team members. So that can be even achieved with multi-tenancy in Istio. Traffic management, it can control traffic management, traffic routing, load balancing, timeouts, retries, failover, all those things can be controlled here. Even like canary, A/B testing, we can manage with the network management, and blue-green deployment. All those things can be achieved. We have support for both cloud and VMs, so it supports both. We can configure our Istio in such a way that it works on both Kubernetes cluster as well as on the VM. Now coming to the last part, which is not last part of Istio features, but it is like in a high level features of the core features which we are discussing here. Traffic performance, we can see like how it is performing your traffic, which microservice is performing how, like if it is totally loaded, or it is taking more time to respond, all those things we can see. Security logs we can see, even auditing like who did what at what time, though all those things can be done. All service dependencies we can visualize, like from where the traffic is initiating and all where and all it is hitting, which and all microservices it is hitting. So that we can, if something goes wrong, we'll be able to visualize at what point that communication got failed, and we will be able to recover it as easily. So this is a simple presentation of like how it looks like when we implement Istio. So like one of the microservice we have taken is transaction management and account management. So if those two microservices want to talk to each other, so we can see here the transaction management, one container will be there on below to that, or along with that one sidecar proxy will be attached into the same pod. And similarly, it will happen for the another microservice as well. So here, for example, we are taking account management, and here also again we'll be having one more sidecar attached to it. So all the communication between these two microservices goes through MTLS channel, like it is secured, and it is secured by certificate. Any traffic entering into this service or from the outside, it is secured by certificate here, and API gateway will have also, like we can have it configured in such a way that any communication coming out of API gateway and entering into our mesh need to be in a secure manner. So this also can be controlled here, and even further we can control whatever traffic leaving out of the cluster, that can be also controlled via MTLS, and like it is going out, that all rules and regulations we can apply here. So this is a kind of high level overview how it looks like. We will go for a demo. So what we will do, we will use our existing setup in the last webinar, which we did, a multi-cluster setup, multi-cloud multi-cluster, like one cluster was running in GKE, another cluster was running in AKS. So we will use the same setup to deploy a small, very simple, small banking application. Like it will have three microservices, dashboard microservice. So like we have made it such a way, like one dashboard will communicate to a account microservice and a profile microservice. So from profile microservice, it will try to get the user information like username, and from account microservice, it will try to get the amount information, like what is the amount currently that person is holding in his bank account. So that we will deploy in our multi-cluster and multi-cloud setup, and we'll see how it is getting. Communications are getting established, will enable our TLS part, like Istio security we will enable, and still we should be able to communicate, and we will verify if time permits, like that communication is secured and it's not open, no one is able to read it. So let's go ahead and deploy application. So for that, I'll give a brief information. Hope my screen is visible and my Visual Studio is visible. So I'll show a little bit information, what all the things I'm going to show here. So as I was mentioning, we'll have one dashboard service. This is our main microservice. So we will be sending request to this microservice, dashboard service. That dashboard service will communicate to profile service to get the information about user, like username, and it will try to communicate to the same service. The dashboard service is trying to communicate to account service as well to get the information about amount currently the person is holding in his account, and that those two information it clusters together and displays on the screen. What we will do, one application will deploy in another cluster, and the profile service will deploy in another cluster, so that we can show that demo in which we will be able to showcase the cross cluster communication as well. So let's go ahead and deploy. So let me open my terminal here. Fine. So we will have two clusters. So one cluster is GKE that we can see here. kubectl get nodes. This is our GKE cluster, and we have another cluster which is AKS. Fine. So it is ready. It is having all Istio installed. If you want to see how it is installed and all that, please refer to our last webinar in which we did a setup, multi-cluster setup, multi-cloud setup in that one. Fine. So let me deploy the first service in AKS cluster. So kubectl apply -f. I'll do account service first. I'll deploy it in second cluster. AKS. Should be context. Fine. So I'm installing account service in second cluster, which is like secondary cluster or remote cluster. It is AKS. So let's deploy the service. So I have created, if you see this, I have created a namespace as well, and it is enabled with Istio injection. So whichever, if any workloads are getting deployed into this namespace, it will have a second container in it, which is a proxy, basically Envoy proxy injected to it. We'll see that in some time. Then let's deploy our deployment, account deployment. Fine, it's done. Now we will deploy our dashboard and profile service in our GKE cluster. And we will not deploy this account deployment into the current like GKE main cluster, but still we should be able to get the information from there. To demonstrate that, I'll not deploy that to make sure it is not getting the data from the current cluster. So let me do it. kubectl apply -f. So let's deploy our profile service, profile deployment to GKE. Okay, namespace is not available, no problem. For that, we need to apply service first so that it creates the namespace. Yeah. Now deployment is done. Now let's do a dashboard deployment. Yes, and then service. Fine. So our all three services are deployed or in place. Yeah, one thing to note, as it is, we deployed account service in another like second cluster, but to have the service discovery, we need to install that service into GKE cluster as well. Not the workload, but the service is required to be deployed in GKE cluster as well. Like all the services need to be deployed in all the clusters, then only it will work. So kubectl apply -f account service. If I'm not giving any context, that is by default. Currently, it is GKE cluster. It's fine. So as we note, I'm not deploying the deployment of the account. Now let's see what all the things are deployed. Kubectl, get pods, banking, multi-cluster. So as we had deployed dashboard and profile. So here we are seeing. So here we can see it is 2 of 2. So one is our container, the application container. Second container is our proxy. So which is injected by Istio. Similarly, let's go and check in a case what we have. Cluster AKS. Yes, we can see account microservice is deployed into AKS cluster, but it is not available within GKE cluster, but still we should be able to get that information. So to ping or to curl to our dashboard application, I'm deploying the sleep deployment from which I'll raise a curl request to our account microservice. So let's go ahead and deploy that in GKE. kubectl apply -f sleep. So here we can see we have 2 versions I'm deploying. The difference between these two are one is deployed into the default namespace and another one is the first one is deployed into the banking namespace only. Like it is within the same namespace, another one is outside. So I'll be showing both communications, like from the outside also we are able to get the traffic and the microservices are responding to that. And even within the microservice also, if within the namespace also, if we have the microservices, they're able to talk to each other. Okay, so let's quickly check it. kubectl get pods. So we can see we have a sleep deployment in our default namespace. And we have in banking multi-cluster as well. Okay, so first we'll start with pinging with this, like sending the request from this microservice or microservice we can say, or sleep pod basically. Let's go ahead and raise the request. For this, I'll be entering into this kubectl exec-90. Sorry, default command. Fine. So we got the terminal. We are into the sleep container and we got the terminal of that. So let's go ahead and fire the curl command. So currently this microservice, it is this pod is currently within the same banking multi-cluster. So I'll be not giving, I need not to give any namespace. I can directly access that application. So the application service is dashboard. Okay, let me show that. It will be easier to understand. So kubectl get svc banking sorry, typo. So we can see we have 3 services: account, dashboard, and profile. I'll be accessing this dashboard service from that sleep container or sleep pod. So curl, so it is dashboard. And currently it's running on port 80. We can see here. So I need not to give any port. And it is listening on a particular endpoint, which is again a dashboard. Okay. Dashboard. So this is a get request, and I need to provide ID to it, so like query parameter, so that we can fetch the information of a particular user. It is a dummy like user. It has been created from 1 to 10. It is having few users which will be queried and returned. So suppose I'm giving this one. So we got the request. So user is Draco Malfoy, and he is having $2K in his account. So similarly, let's go ahead and fire suppose 3 or 2. Okay. So we can see here, like one, we are getting response from this. This is the pod name, basically. Profile is the pod name that we'll verify quickly. And the account, this is the pod name of the account. So let's go ahead and verify the name, basically. So kubectl get pods and banking multicluster. So we can verify this one, this profile. So profile name should be matching with this, right? It's matching, perfect. And here we can see we don't have any account microservice running in the GKE, but still we are getting the information. So let's verify what is running and what's the name of the pod in another cluster, which is AKS. So let me add context and then try to find cluster. Yes, so we can see from pod. So this is the pod name. We can verify. Perfect. So we saw we were able to get the information from all the microservices within the cluster and across the cluster. Like another service was getting a request and responding from another cluster, and we were able to get the information from both the clusters. Fine. Now we will enter into the pod, which is running in a default namespace, but still we should be able to, like, it should behave the same way. We should be able to get the response. So let's try that as well. kubectl get pods. Let's enter into this. kubectl. Here, when we fire a curl request, we would not be able to get directly dashboard because it is not there in a default namespace. So that we can try, it should not work. So for that, we need to give namespace also. So let's do it. And dashboard. Three. So dashboard, because it is not getting identified. So we need to give namespace. So namespace was banking multi-cluster. Perfect. So we are able to access the application which is not into the same namespace and which is not even like Istio is not enabled for that. So we can see also here it is having only one container in it. And all those these were having two containers. One is actual application, second one is the proxy container. And it was working currently, and it was accepting both the request, because by default, when we deploy Istio, it accepts both the request, like either TLS or non-TLS, plain text as well. But if you want to restrict it to only TLS, that also possible. We can do it across the cluster. All the communication need to happen over the TLS. That is possible. We can do. Okay, I could see we have some time. So what we can do, we can verify the communication if it is happening, like the communications are secured or not. So for that, I'll bring one more terminal here. And we'll log into one of the container to see whether the request, whatever request we are getting, it's encrypted or not. So let's go ahead and log, try to log one of the container, a dashboard container. Basically, I'll do that. Get pods. Fine. So I'll try to enter into that. Sec. So I'm trying to enter into the proxy container so that I can log whatever request it is getting and dump it in using TCP dump. So for that, I'll use Istio proxy. And then I need to give banking multi-cluster. Then default command, I can give it sh. Okay, so this banking application internally, it's running on port 8080. I'll be tapping that. So sudo TCP dump. And I can listen on port 8080. Fine. Now let's try to enter into one of the pod. Multicluster, okay. Let me make it small so that we should be able to see it. Passport, typo again. ID, I gave something maybe 8. So we got log here, but we are not able to read anything as such. Okay, let me try to run this command on both. Sorry. Sudo AT and port 8080 as well. So we can check both. Let me fire the request again. So we can see the data we are not able to read, or we don't have that information here available. Okay, I think I need to put all the packets. So let me log all the packets. Currently it's not logging. If in A port 8080. Fine. Yes, so it was only printing the header part. Now we are having data as well. So we can see all the data, whatever we are seeing here, it is encrypted, including the header. That HTTP header also we are not able to see. All those communications are encrypted. We can verify that. Okay. So this request I sent from the container or from the pod, which was already within the same namespace, and all those communications were happening using MTLS encrypted part. So now let's go ahead and try to do the same thing from the outside namespace, which is not Istio enabled. So for that, I can directly enter into this one. Okay, I got it. Now I'll send a request. So we are able to see from, like, we are able to send the request from outside, but we see here we are getting the data. We can read it. It means when we send the request from the outside namespace, which was not having Istio enabled, it sent the data or sent the request plain text, and it got the response in plain text only because it was not, like, MTLS was not enabled for the default namespace. So here we can see, and it is possible selectively we can enable for microservice which we want to communicate over MTLS, and we can leave others as it is. But still we will be able to communicate and make our things work. So it will not basically disturb any existing deployments or any existing microservices. All those things will work as it is. Fine, perfect. So we deployed, we saw cross-cluster communication. Now we saw the communication between the microservices, which was both, like, we can enable encryption and non-encryption also. Perfect. So yeah, that's it for today's demo. Debasri, over to you.
Yeah. So first of all, thank you, Ravi. Thanks a lot for explaining the concepts, how to secure multiple services that are deployed into multiple clusters, multiple cloud, or even in the same data center. It can be if there are multiple networks. How someone can secure the data in transit. I think that was the most important factor, which is required for banking financial institutions to not only comply to the regulation standards, but also to avoid any reputational damage. Thank you for that. Now, quickly, before we close the session, I just want to kind of highlight the offerings of Istio that IMESH provides. So we have two flavors right now when it comes to support and services. One is securing production Istio. So what we IMESH offers is to supporting the installation and implementation of Istio for your production with custom integrations, or supporting Istio to implement it for multiple clouds, including different versions of Kubernetes in EKS, AKS, or GKE. Plus, if you want to implement Istio for virtual machines or legacy environment, we can do that. So that's a part where we help you provide certain kind of handholding to implement Istio for production. Then we also provide enterprise Istio support for ongoing maintenance and service of Istio, where we provide guaranteed SLA, ensure that your Istio is performing at optimum level and doesn't consume a lot of resources. We do the optimization. Simultaneously, we also take care of regular patching, security patching, and lifecycle management, like upgradation from previous version of Istio to N+1 or the recent version of Istio. That's what it is. So please let us know in comments if you need any help. Please feel free to reach out at contact@imesh.ai, and have a wonderful day. Thank you. Thanks a lot
Thank
for
you.
joining us.
Thank you,
Bye-bye.